Hey, it's Mrs. Cat, and I am here with a three levels review or three levels chart for compounds. It's our first one of Unit 4. We're going to start by defining this as two or more different elements that are combined chemically to make a substance. At this point, we've looked at compounds in a number of different units, and we've looked at them in a variety of different ways. We're really going to focus on what we've done so far in Unit 4 to add onto our three levels chart. So let's take a look at our macroscopic level first. I'd like you to go ahead and split that macro box into three sections. We're going to use two of them today, and we'll use that third one at a later time. We're going to start with the iron and sulfur demonstration. And we're going to give macroscopic evidence for the fact that iron and sulfur combined chemically to form a compound. So let's give a description of those. The iron was a dark gray metal. And it had metallic properties, where the sulfur was a yellow powder, and it was non-magnetic. I wrote metallic over here, didn't I? I meant to write magnetic. Okay, so we can mix these together. You could separate the iron out with the magnet when they were just mixed together physically. Something else about the iron is it doesn't have an odor, where the sulfur smells like rotten eggs. Once those two elements were combined chemically through the process of it being heated, we wound up with the compound, which is iron sulfide. And just with our macroscopic observations, we could tell that that was a completely different substance. So this was a gray solid. It was definitely a different color than the iron was originally, and it was also non-magnetic afterwards. Okay, so it took on completely different properties than the original elements of the iron and the sulfur, its original components. Okay, that was the first demonstration. Second part, demonstration or lab, I'm going to pick a slightly different color of blue, is the electrolysis of water. Okay, I'm going to do my very best to sketch a setup of this little lab. So I'm going to start with my little trough of water. We make that a little higher. And then I have two test tubes that were turned upright in this. And then we have liquid, that's water, right, in the basin. And then we also have liquid that goes up into these test tubes. Okay, so let's label what we have. This is water. Up here, we've got gas in the top of each of these, and the water has been pushed down. We've got oxygen gas here on the right, and we've got hydrogen gas on the left. Okay, two important things to know about this is that each side of our setup, after it was connected to the electricity, created a gas. Second thing is that we have different amounts of gas. So the water splits apart into two volumes of hydrogen, but only one volume of oxygen. So I did my best to try to make it look that my hydrogen volume was twice that of the oxygen. Again, it's not going to be exactly perfect, which is why we're putting that note in there. Okay, again, we're going to leave that last part for a later time. Okay, let's add a couple things into our particulate space that goes along with each of these examples. I'm going to change colors here, and I'm going to show this combination of iron and sulfur to make iron sulfide at the particle level. Okay, I'm going to do my best to match up colors. That's not really dark gray, is it? Yeah, that's better. Okay, let's go a couple of iron particles in that dark gray. We're going to go with a couple sulfur particles in the yellow, and then we're going to make them into iron sulfide, which means we're going to need one iron particle and one sulfur particle. We are going to make them touch to show that they are combined chemically. And then I'm going to go ahead and add in my addition and my equal signs to show that. Okay, so showing the difference between our atoms of our individual elements and our molecules of our compound iron sulfide. Kind of a little review from our particulate identification from the classification of matter notes. Okay, so we also had water in the electrolysis lab. I'm going to represent this a little differently since we talked about the individual atom types. Okay, I'm going to label these with the element symbol. Okay, hydrogen symbol is H, oxygen symbol is O. We can make the assumption, or it's not actually an assumption, we can gather from the data we have from the electrolysis lab that there are going to be 2 hydrogen atoms combined with 1 oxygen atom to form water. Okay, and again, we get that from the experimental data that we have from the macro evidence of 2 volumes of hydrogen to 1 volume of oxygen. That actually leads us to our chemical formula for water, which is H2O. So a chemical formula we're going to put in our symbolic space. This is the last thing we're going to put on our 3 levels chart for now. And we're going to say that a chemical formula specifies the number of each atom in a compound. Okay, so again, I'm going to redraw this in orange just because that's what I've got color-wise. Okay, if I've got H, O, and H, okay, this tells me that I have 2 hydrogens for every 1 oxygen, so my chemical formula is going to be H2O. Again, giving the number of each individual atom type in a compound. So that's what we've got for compounds so far. We will be adding to this next time. So make sure that if you have any questions that you reach out to me or to your individual teacher so you can get those taken care of before we go on. Thanks.